Synthetic division is a shorthand or shortcut method of polynomial division in the special case of dividing by a linear factor. Synthetic division is important because it is a quick and easy way for us to find the limit of an equation where a certain x value is undefined. This is our equation, 3x cubed minus 11x squared minus 21x minus 5 all over x minus 5. And we want to find the limit as x approaches 5. But if we just plug it in, it doesn't work because we get negative 10 over 0, and you can't divide by 0. So we have to use synthetic division.
Alright, so clearly we can't just plug in 5 in order to find the limit of this equation as x approaches 5. So what we're going to have to do is use synthetic division. Now, synthetic division works by removing this linear factor on the bottom so that we can actually plug in a number that may cause a 0 on the bottom in order to find what that value would be. In order to do synthetic division, you take whatever number you're approaching and you plug it in right here, and then you take the coefficients for all of the factors on top, so that being negative 11, negative 21, and negative 5, and you plug them in on top here. You're going to bring down the first number just automatically, and you're going to multiply it by whatever number you're approaching. In this case, it gets 15. And then you're going to add these two numbers together and put the sum right here. And you're going to rinse and repeat. So 4 times 5 is 20. These added together is 1. 5 times 1 is 5. These added together is 0. You should always end up with a 0. Otherwise, you didn't really do it right, or it wasn't something that could be divided evenly in the first place. And then you take these numbers right here, all 4 of them actually, and you're going to plug them into a new equation. So that's going to be, you're just going to take the degree down by 1. So this is going to turn into 3x squared plus 4x plus 1. And then you have to put the factor that you divided it by in the equation as well. But now these can cancel out, and we can plug in a new number, or we can plug in a number to get a new number for the limit. As you can see, in y1 is our original equation of the one that we had up here. I don't want to repeat it. And as you plug in 5, you get an error message, of course, because there's a hole. However, if you plug in the equation that we just found using synthetic division, then our table shows that at 5, our value is 96. That matches up perfectly with our value here. If you plug in 5 for each of the x values in the new equation that we found, you also get 96.
As you can see, we have found that the limit of y as x approaches 5 is 96. We chose synthetic division for our video because neither of us were very confident in our ability to do it coming into this year, and long division with polynomials is always a pain to do. We both wanted to strengthen our abilities on this topic, so we decided to make a video on how to do it.